Scott, welcome on. And I will say, as a fellow, at the time, envelope specialist, but observer, I actually came across you in your talk in 2018 at the Green Building Festival.
Wow, nice.
And you were talking at the time about the existing building conundrum. And it's funny because I rewatched it last night, and 8 years later, not much really has changed.
Yes.
So a lot of what I want to talk about today is some of the similar challenges and factors and constraints that existed then and exist today. But I guess it would be good for you to start off and share what got you so interested in existing buildings, and enough so to truly believe I need to get on a public platform and start preaching.
Yeah, good question. Thanks a lot for that intro. I'm always curious to see how people may have crossed paths with me before, and we've kind of been, I guess I would say, LinkedIn buddies for a few years and sort of trading posts and comments back and forth, and it's been really enjoyable. I think from my perspective, existing buildings are the biggest challenge because they exist. I mean, just the fact that they exist and that buildings are not static entities, that buildings require constant work, constant maintenance, upkeep, and retuning. They don't exist in a vacuum. They don't stay at the same level of performance for their entire life. It's like usually its best performance is day one when you hand the keys over, maybe with a little bit of commissioning put in there for good effort. And then from there, it's pretty much just a downward trajectory. And then you kind of inject new life into existing buildings throughout their entire call it useful life. And then useful life, you get into, is it functional useful life, is it performance useful life? There are just so many ways to look at existing buildings, and I saw this trend or this tendency to manage existing buildings as kind of a capital cost as opposed to an opportunity for investment and improvement, and really just kind of wasted cost. So that's kind of what got me into this idea, and also recognizing, not that I was new to this idea, but picking up on what some of my HVAC and mechanical friends talk about in terms of servicing loads and making sure people are comfortable, and pairing that with my understanding of climate change and how the environment in which these buildings exist today is not the environment in which they were designed for when they were built, and certainly not the environment in which they will need to perform 10, 20, 40, or 50 years from now. So, kind of that's a lot of layers to say, like, we've got a really, I think, interesting challenge, a real technical challenge. There's obviously a lot of pricing challenges. There's a labor availability and knowledge challenge. Like, there's just so many layers to existing buildings. I'm equally passionate about new buildings too, but I mean, I feel like existing buildings are a unique area of work.
There's two things from the talk that stood out, or that I think in my head. One, you were very adamant about everyone going on the walking tour, so I do want to hear how the walking tour went. And then second to that, you were talking about the idea of ROI, whether that's in terms of, we're not going to talk on the operational carbon or embodied carbon side, but from an owner standpoint, because that's who you're ultimately trying to sell. It's some entity who's holding on to that building, and you want to validate or justify spending that money. Usually they'll go to lower hanging fruit, mechanical, lighting, building automation, but to have them go from leading with the envelope. So how has your communication style changed to clients in terms of maybe wanting to preach what you wanted to preach early on versus trying to understand what's going to resonate with them to make your style more effective?
Yeah, great question. My style has changed in that I am much more attuned to the business case, much more attuned to anticipated capital spend, and how we can achieve, or I suppose not miss, a generational opportunity to improve a building. And so I'm speaking a lot more on with owners and with developers on not wasting your capital, right? You have to leverage your capital so that in the end, it's not just a cost, it's an investment. And so you're actually moving the needle on performance, which otherwise you're just throwing away capital. You're throwing capital at a problem, and you're basically reverting back to the original design intent, which, again, if we're talking about a building from the 1970s, 1960s, even 1990s, those are old ideals of what the design intent was in terms of performance and comfort and daylighting and all of these things. So, and when you talk about the building envelope, these are very, very substantial costs, right? Reglazing a building is a very expensive prospect. Re-skinning, taking the skin off and replacing it with something new. I mean, again, these are very significant projects. They're very disruptive. So focusing on, trying to keep people in the building. So most of my existing building work, re-skinning, re-cladding has been done in occupied buildings, not empty buildings, both residential and commercial. And kind of expressing that as like, you don't want to start losing that income, right? Because you want to keep generating income so that you can continue to pay the operating expenses. And then ultimately, in the end, you probably end up with a more valuable asset. People might be willing to pay more for their rent or their lease agreement. And so there's kind of see it as an investment and not missing a wasted opportunity. On the topic of walking tours, I mean, I love walking tours. When I go to cities, when I travel, I'm almost always doing like a food tour or a walking tour or, the hop on, hop off bus tour, just to kind of get a lay of the land and see the work. I mean, this is one of the things that I love about my job is that my work is all around me. And I love observing it. And I really love sharing that observation with other people. And so the walking tour at the Green Building Festival, we went from the conference center down and toured kind of a downtown, maybe 3 or 4 blocks around the conference center of all the buildings that we've reskinned in downtown Toronto. And some were in process and some were, I think one was in the design stage. A couple were under construction. So it was a way to sort of show people, and my philosophy in life is like, look up, right? Like all the interesting stuff is up there. Like there's still interesting stuff that happens kind of at eye level, like, retail and stuff grabs your attention. But I mean, the really cool stuff happens up there. And so getting people to kind of look up, experience their city, see these buildings being transformed in front of their very eyes is and to be able to touch and feel it and kind of experience it that way. I think we had a couple hundred people on the walking tour. Like it was a substantial number of people from the conference decided to go on the walking tour. So I guess I did a pretty good sales pitch. It was quite a lot when you're trying to cross like busy downtown streets. But at that point, pedestrians rule, right? So like if you just go as a big enough mob, then you're going to be able to cross the street. So it worked out really well. It was fun.
If you think about the possibilities of upgrading an existing envelope, I guess you could think about it in terms of functionality. So maybe you are incorporating some type of natural ventilation system or operable windows instead of fixed. There's the energy aspect of it, so you could upgrade the glazing, but just adding more insulation at the opaque area, you might see an energy payback, but it's going to be probably hard to justify the ROI in terms of, you're going to see a payback in 3 years. They're probably thinking on a longer term horizon. Then there's the aesthetic component of it. If you want to clad or decorate the spandrel or opaque area from the outside, do you think what will resonate with an owner most is trying to help them see, part of it is like, can you create a competitive landscape? So this guy's got a Class B office, next door he's got a Class A office. All of a sudden, this guy feels if he doesn't do something with his building, he's going to lose tenants. So do you think that's maybe the biggest opportunity zone in terms of helping people understand you upgrade your area in terms of occupant health or comfort or user friendliness, you're going to attract a higher quality tenant and be able to demand higher rent per leasable space?
Yeah, I do think that's true. I can share an example. I won't use specific names or addresses, but one of the re-cladding projects I worked on here in Toronto, it was 2 kind of mid-century buildings, 60s and 70s. A lot of development had happened around at the time. An adjacent building had also been reclad. And so on their very property, they had a brand new building that they had just built. And there was these 2 existing office buildings that were experiencing, relatively high rates of IGU failures, fogging, and issues that tenants were having concern with. We were in the process of just kind of managing IGU replacements, right? Maybe doing a floor at a time or doing like 100 units a year or something, but constantly falling behind. And so again, at that point, we had the conversation with them about, this is not, you're sort of not really getting the best value out of your money, right? You're sort of chasing a problem that you will never catch, and you're not adding any value to the building. You're basically just stemming the sort of deterioration of the value. And so we did a number of recladding studies and came up with a concept of 100% IGU replacement and 100% spandrel replacement while the building was occupied. And we actually worked with an architect and a curtain wall manufacturer on a pre-glazed option. So sort of a cassette frame that we could, take out the IGU, take off the spandrel, and immediately put in a new pre-glazed cassette system. we did all the background on the structural side to make sure that the existing frames could take it, but all the existing curtain wall framing stayed in place. And it was interesting because once that project was announced, their churn rate dropped. People renewed their leases, and they renewed at higher net rents. And they were kind of looking at the financial side of it and sort of being conservative. And to be honest, that accelerated the value of that building, even just saying they were doing the project. And they ended up getting a huge lift on their on the value and on what people were willing to pay for that property, that returned the value to them in a significantly higher rate than they were anticipating, right? So all their analysis, so that they were able to justify, yes, this is a good investment, we should go ahead with it. It surpassed all expectations. So, and that was just at the announcement stage, right? So like I think that's the value of showing people that, yes, we're investing in your space, we're improving the space for you, we're kind of making a more attractive asset. There was an architectural desire as well to kind of tie these buildings together as a bit of a campus, right? So again, these were fairly typical, vision glazing and metal spandrel. And so the new aesthetic, one includes a shadow box, the other one includes just a reflective glaze spandrel. So again, just kind of bringing the architecture into a more contemporary palette, matching up with the adjacent buildings that were built to kind of stitch these buildings back into their campus and kind of create that sense of destination and place. So it's really amazing project. And so I think shows the value. And I guess I should temper that a bit with, we've had the real challenge in the office sector in the last 5-6 years with COVID and return to office suppressed, and those challenges that are going on in all kinds of cities around North America for sure. The good thing is that, and so that type of work has kind of tempered, like that whole market demand has kind of softened. But I have seen in the last sort of 6 months or a year, it feels like that trend is shifting again. I feel like we're kind of at the beginning of another wave of these kind of reskinning, re-cladding type projects in the commercial office sector. And it's largely driven by exactly what you mentioned about, you've got tenants here who want to go to this pretty new building, or there's a real, at least we're seeing in Toronto, there's a real kind of split in vacancies across the classes, right? So Class A in Toronto, I think the last I heard in January was about 3.5% vacancy. Like it's extremely low. Whereas Class B and C are like still 13+%, right? So there's a huge split there. And we're not building any more Class A. Like there's some that's coming online, but after that, there's no supply. And so that vacancy problem is not going to go anywhere. And so really, I think there's this opportunity for the maybe marginal A or B type buildings to kind of reimagine themselves and attract tenants who want that kind of Class A space for which there is no supply. And so it's these sort of, call them marginal A or maybe Class B buildings that are probably that 80s, 90s era, right? That are looking a little bit tired. Maybe the cladding is faded. Maybe they're accelerating their IGU failures. There are these other issues. Maybe they're planning to do a plant replacement on the HVAC side. Well, that's the perfect opportunity to do something meaningful on the enclosure, right? To get more value out of it. And then I always connect the envelope to the HVAC because, like you said, envelope is not going to pay itself back straight costs. But in my experience, it is a low carbon enabler, right? It allows you to do low carbon HVAC solutions. So if you have a very poor performing envelope, a lot of air leakage, poor solar heating management, low thermal performance, those are all seriously challenging for servicing with low temperature, low carbon, and like things like dedicated outdoor air and those types of distribution systems, right? So you have to kind of pair those things. You have to kind of create this enabling enclosure that allows you to decarbonize on the HVAC side. If you don't have that kind of higher performance on your envelope, these systems can't output enough energy to compensate for that, right? So
if you think about when you're on that note, so more on the nitty-gritty side of performance of the components, if you think about like driving in your car and the recommended tire pressure is like 33 to 34 psi per tire, and you're watching it and it's at 28, 27, you're like, ugh. you get below 22, I don't know, you got a problem, and then the tire's blown out. When do people call you? What PSF are they at where they have a problem?
Yeah. Every owner is different, to be honest. I mean, some are very proactively at the pump every day, checking the tires and making sure they're at exact pressure. So we're doing IGU surveys, right, to kind of catalog and document what their failure rates are. Is that failure rate accelerating? We could do frost point testing, right, to kind of test the IGU in situ to give you at least some sense of predicted future life based on the testing standard for that device. So, and then there are the others who are really just chasing the problem, right? They're managing IGU failures with an ops team and maybe a contractor they have on call. They're doing one-ofs here and there, or maybe even, significant numbers at a time. And it's not always us that gets the call. Sometimes it's an architect who gets the call, right? Because this is an opportunity, again, architecturally, to kind of really refresh a building. And we're more than happy to kind of drive on the technical side and help work on those types of solutions. We really enjoy working with good designers who are also technical, but then, certainly have the design sensibility that I don't, to offer those kinds of upgrades or those modern palette type solutions that bring the building more to the current era.
In a new construction environment, or I don't know, setting, it's all about optimization because you're starting from ground up. So you can run your energy model and play with the structure versus mechanical versus envelope, and you have the designer and you and everybody working and contractor selection. Obviously, existing buildings, you're left with what you're left with, and you got to deal with maybe a contractor that might not be in business anymore. I know you're going to say it's not more important one or the other, but in terms of having that envelope specialist in new construction versus existing building, things that come to mind are stuff like even as simple as adhesion testing. You're going to apply new perimeter caulk joint to a substrate that might be unknown. Or what are you going to do? Rip it out and bring it to a lab and have Dow or GE or whoever do the testing, so they'll give you your 20-year warranty. Contractor's not going to want to own that. So stuff like this, adhesion of sealant, compatibility, even assessing the existing structure, you can understand why a contractor wouldn't want to own liability there. So in that case, where would you have an impact that you otherwise might not be relevant in new construction applications?
So that deep understanding of existing conditions and how it affects the solution on the retrofit side, that's really where we shine, I think, just because of our dual experience with new construction. So we understand new systems, we understand how they're built. We've worked with a number of manufacturers to develop prefabricated panelized wall solutions, right? So we really understand the engineering side, we understand the manufacturing side, the construction side, and the design side from the new build perspective. And so we can kind of bring that knowledge to the existing building space. In some ways, that new construction experience is why I like both types of work as an individual. I feel like it gives me X-ray vision for existing buildings, because like I've seen new builds from component by component built up from nothing. So when I look at an existing building, I can have a pretty good sense of what's there just by looking at it, right? You look at both sides and you look at, the anchors and things, and you're like, yeah, I kind of understand how this is built, and I think I know what the guts of the system look like. You still have to do the engineering analysis. So in all of the cases where we've done re-cladding or re-skinning, re-glazing / re-cladding is more relevant to the kind of existing building condition. We've looked at the mullion framing, we've looked at the anchor. So there's like kind of, I would say, three main connections, right? There's the mullion itself, which is a relatively easy analysis from modern wind exposure and compared to old code. Then there's the anchor connection to the mullion, right? So what's the condition of that? Can it withstand additional load? Or in the cases of re-cladding or putting on a panelized or cassette glaze system, moving that moment out further, right? That also creates an anchor problem. So it's like anchor to mullion, anchor itself, right? And then anchor to slab or anchor to structure. And then in some cases it's embed to structure, right? So like you kind of have at least three, maybe four kind of key connections that are critical to understanding whether or not this system can accommodate the retrofit solution that you're conceiving of. And it's run the gamut for me. Some buildings, tons of extra load, no issues with the anchors, no issues with any of these connections, no issues with embed. So we've chipped out slabs, looked at connections to rebar, looked at embed plates, just to kind of understand what those conditions are, and then run that against the re-clad or reskin proposal. Others, no, like you need major anchor upgrades. Like one project, we had to add all new anchors to the vertical mullions to supplement the existing anchors, which were undersized. And in fact, on that particular building, we saw stack joints closing, right? We saw some issues in the curtain wall that we then had to remedy with the re-clad.
That's what I wanted to ask you on that point. I think that's important that people don't think about it. If one of these buildings was designed in the 50s or 60s and you didn't have a project-specific wind study done to understand what's going on at your extreme conditions, what's something you've learned in terms of, are you starting from that baseline, or are you starting from today's code and today's imposed loads, and then maybe uncovering, oh shit, we're 30% undersized on existing conditions, we need to upgrade just to get to baseline, and then consider any additional components that might come outboard of the existing wall plane?
I think the investigation often informs which path you end up taking, right? So if you start doing the analysis and you realize, as it was the case with this building I was thinking of mentioning earlier, the existing curtain wall system was under-designed for its original design intent, right? So that's an origin issue, right? It has nothing to do with the fact that we're reglazing or reskinning this building. It's a latent defect, call it. So then at that point, you kind of can't ignore it, right? Unless you're willing to just literally ignore it all and sort of turn a blind eye. We would probably have to write a letter saying, hey, we discovered that this is not, not structurally sound, which is obviously an issue for the owner. Or you discover that everything's fine and you can actually bring it into kind of modern day codes. And then that kind of depends on the scale of the retrofit, right? So if it's just reglazing, again, you don't necessarily need to assume modern codes. You're just doing like for similar, maybe you're improving the coatings, you're adding argon, you're doing a warm edge spacer, you're adding non-metallic pressure plates, something just to kind of get a real lift on performance improvements, but you're not really changing the fundamentals of the system. But if you're swapping out metal for glass spandrels, or you're adding insulation, or you're doing a raised hat solution, or you want to go to VIGs or triple glazing, at that point, I think you're kind of forcing your hand to go to look at it from a current code perspective. The other thing that I've discovered is that, or have had experience with on these retrofit projects, is sometimes wind studies can work in your favor. And, the urban centers have changed a lot since the 1970s. And so some of these buildings that were kind of all on their own in the middle of a parking lot, they're surrounded by other buildings now, and a lot of taller buildings in some cases, right? So that can be good, it can be bad, right? Like it could create that wind tunnel effect and increased suction pressure or whatever. There's lots of different ways it could change. But I've seen some buildings, I had an experience where the wind study actually allowed us to reduce the loads on the cladding system compared to just a standard code evaluation.
When it comes to it, that's very interesting. And I do wonder how, maybe in today's world, maybe not, you can start designing a building, understanding what's going to happen in the next 5 to 10 years in terms of surrounding builds. But when it comes to utilizing the sun for what it's meant to do, and passive solar heat gain, using it in a Toronto, a heating dominated climate, using it to your advantage, have there been instances where, like you said, maybe a building was either at the detriment of too much solar heat gain, or it was using it to its benefit? All of a sudden you have a high rise next to it and the elevation is completely shaded.
Yeah, before we get into that, because I do have a very good example for that, but a point of clarification is Toronto is a heating dominated client, certainly for residential. In commercial, we cool almost year round because there's just so much internal gain. Even so, commercial office,
because the buildings are so highly glazed.
No, just because there's so many people in them, right? So you've got all these people and all this equipment and all these lights that are generating heat. So really, we're kind of managing heat loss. We're heating the perimeter, but we're almost always cooling the core.
So on that note, it actually makes it super challenging understanding what's the building use case, especially now when you're converting these office buildings to hospitality or hotels or residential.
100%. Yeah.
And how it's originally designed for one use case, all of a sudden, like you said, and I don't think people appreciate how much mechanical load plays into, well, are all the tenants coming in at night and having to heat the area when they're sleeping and then gone during the day? Because you have the opposite problem with office space.
Yeah, I would expect that to be, I mean, we build a lot of condominiums with the same type of cladding, right? Window wall versus curtain wall. And so this, we could unpack that for days, whether or not there is, but I take your point, and I think it's very valid that repurposing or conversion idea, you really need to understand what the cladding system is providing for you from a thermal comfort perspective, solar heat gain, air leakage, these aspects, because you're right. If I put my bed next to a fully glazed curtain wall system from the 1970s, like I'm not going to sleep well, or if you love sleeping outdoors, you'll sleep just fine. So let's talk a bit about solar heat gain. And I recognize too, a lot of the examples I've used are commercial office, because those are the large reskinning or reglazing opportunities that tend to exist. But residential, Toronto has the tower renewal program or tower renewal project, which is really interesting, worth looking into. A ton of research was done a number of years ago on repurposing or retrofitting existing apartment buildings. So these are all 15 plus stories. They're what we call concrete slab buildings, right? So they have usually projecting balconies. They've got the big shear walls on both ends. They're usually brick clad. The slab edge, even in those cases, is often expressed, right? So you see like a slab edge and then brick directly above it, and then a little strip window, and then a slab edge and a brick strip window. And so there was a lot of discussion about what to do with these aging assets, and there's lots of really interesting solutions. Some of them have, we're working on one right now here in Toronto. It is also remaining fully occupied. We're applying a prefabricated panelized wall system to the exterior as a new cladding on the outside, and then basically taking the old window out and leaving all of the existing interior walls. And retrofitting in an HVAC solution as well at the same time. So we're basically reskinning the whole building in an occupied situation with a prefabricated. So the speed is relatively quick. Now there's a ton of coordination needed, right, to anchor that new system to the old building, understanding construction tolerances and variability and creep and shrinkage, like all these things that have happened to this existing building over the years. So I guess I departed a bit from your question, but there is a very different approach, I'd say, or a different set of problem statements to solve with residential versus commercial. And again, you could apply that to institutional, you could apply it to transit buildings. So the solutions I've been talking about, commercial office, there's lots to unpack there, residential, lots to unpack there. I will share another commercial office story because it's very relevant to your comment about solar heat gain. Had a client downtown here in Toronto, not a super tall building, like maybe 20 stories, about 20 stories tall, very, very highly glazed, kind of, mid 1980s-ish, not amazing solar heat gate control, right? And very substantial comfort issues with their tenants. I had done a study for them a number of years ago on retrofitting with an interior solar control film. That was before dynamic glazing was really in the market. So we measured solar heat gain through the glass without the film and with two different kinds of film. I set up a bunch of temperature sensors to kind of monitor what's the temperature differential at the glass versus at the thermostat, right? And can you kind of tighten that band so that the thermostat is giving a more accurate representation and giving heat and cooling based on the actual temperature that people are experiencing when they're 5 feet from the glass? The solar control film did provide a little bit of that tightening in the temperature differential, which we interpreted as being a comfort improvement, right? Because now people at the perimeter are experiencing the same temperature as the people near the thermostat, and the thermostat's responding to where the thermostat is, not where the people are. So that was fine. We went ahead with a couple of retrofit locations. Now, a number of years later, they still had the solar heat gain issue on other floors. And so we did another solar study. So we looked at insolation, so the amount of solar radiation hitting the building in a model, but we added context for buildings that we knew were in the pipeline or soon to be under construction. Sure enough, there was a 40-something story building being built on a neighboring site. And so in our model, we showed, what, if you just wait a year, this problem's going to go away. You won't need to add any film. So we sort of convinced them, like, don't spend your money now. Like, if you can kind of say, look, we understand this is an issue. We'll work with you to make sure it's comfortable. Maybe we provide some better blinds in the interim, but in reality, like in a year, it's not going to be a problem anymore, right? So understanding that urban context is really important.
Have you had the chance, and maybe I'm a little just skewed on the other side of this, had the chance to live in high-rise construction in an urban environment? I mean, I did so for over 10 years being in New York City. And the things that you push or you talk about versus the actual living space you want to experience and live in might change. And what personally to you, what matters in a multifamily residential application? What's important? You're either visiting somebody or when you were living there, what would stand out to you the most?
Yeah, I did live in a condo. I mean, we were on the fourth floor, so but it was pretty typical condo construction. I think what mattered to me was daylight, right? Like I wanted connection to outdoors, and the space provided that. Although it tends to be the window at the end of a kind of a very long, narrow room, right? Which that can be a challenge, but certainly daylight, connection to outdoors. I did have a balcony that I never really used. I used it to finish and stain some of our baby furniture when we were having our first kid. So like it was handy to have an outdoor space that I could just pop out and do a little bit of woodworking and then come back in and let it dry out there. But we never really sat out there much. It wasn't really a nice environment, but psychologically, I liked knowing that I had access to outdoor space at my at the level of my unit, as opposed to having to go to common space or having to leave the building entirely. Acoustics were fine. Like I never really had an issue with acoustics. The HVAC system was a bit loud, right? So I kind of found that noise was a bit of an issue from inside the unit. And then I'll share an anecdote. I had another client. We're working on a residential building for them, and you might be familiar with the isocorb or like the slab thermal breaks that you can put. So that's gaining a little bit of traction in Toronto. There's a couple of very prominent buildings here that have put it on the entire building.
For what you were describing, that cantilevered slab that sticks out.
Yeah. So basically, you've got this huge piece of concrete going from inside to outside. It's whatever, minus 10 C outside, minus 15 C. Well, all that heat loss is making the interior slab cold. That's a comfort issue. It's potentially a condensation and moisture risk issue, right? If there's a dew point that's inside your space. And so we were having this conversation with a client, and we were talking about slab thermal breaks, and we were trying to kind of move envelope performance up a little bit on his radar. And he was very interested because he had spent the last 2 years living across the street at one of the buildings that they had built about 10 years ago. And he said it was one of the worst experiences of his life because it was so uncomfortable. He's like, the slab's always cold, the windows, like I can't put my couch within 3 feet of the windows because I get all kinds of condensation. I can't sit there because I've got downdrafts. Like he connected the dots, right? As a builder, really interesting kind of. At that point, then you start to have a much more substantive conversation around this issue of comfort and how comfort and thermal performance are very much connected.
So, isn't it weird that word comfort, though, means something different to everybody?
Yeah,
and to me, the idea of not having operable windows would be uncomfortable, where to many it would be foreign.
Yeah.
And, I got to have at one point had a balcony, and to be able to use it 6-7 months of the year was the greatest gift of my life, being able to just go outside and get fresh air.
Yeah.
I don't know how it is in Toronto, local code wise. In New York, you got 5% of your floor area needs to be naturally ventilated through operables. So it's kind of standard practice, but there's a lot of markets in the US market that operate with predominantly fixed glazing and residential applications, and maybe have balcony, one per each residence, but you have 3 or 4 rooms that are not naturally ventilated. To me, that would be super uncomfortable. The idea of what you just said about daylighting, I think people conflate that with more glazing.
Oh, 100%. Yes.
And I think your window to wall ratio, it's more about effective placement of the glazing, right?
Yes. Yeah. Yeah. Because if I look out the window, at any one of the condominiums here in Toronto, even on a winter's day, all the blinds are down, right? Because they're overlit, right? There's just too much glazing. So now imagine we go to summer, it's 100 times worse, right? So I had a presentation a number of years ago, called Beautiful Views or Solar Ovens. And I was kind of analyzing this connection between too much glazing, in service of this beautiful view, when in fact you end up just cooking yourself in the summer, right? And it's so that, yeah, I agree with you. It's more about wise placement of the glass. It's about right sizing the glass. It's about having the right visible light transmittance.
Let me ask you this one, because I think it's super relevant to your market, and we could talk for a very long time. So I got to keep this focused and wrapping it up on when it comes to vacuum glazing and retrofitting existing buildings. I've heard just so many different perspectives, and talking to a lot of people in the US about the use case and how much it can really move the needle in terms of, let's not talk about the whole, you'll hear R15, R20 center of glass. That's not the whole perimeter value considering the edge. But in terms of, okay, if we only have 40% window area, 30, 50, you put this supercharger in your glazing area, that's going to offset a lot of the opaque. So all of a sudden, sort of, maybe we don't need it per code, but if we go 20, 30, 40% above that, all the rippling effects and positive benefits that could come of that. Wouldn't it be ideal use case in an existing building renovation, in Canada? I don't know, it's a very broad statement, but you'd think this would be an unbelievable solution.
Yeah. I mean, VIGs are interesting in that the technology's come a long way, right? Certainly people are more comfortable with it now than they were 10 years ago. I still think there's some hesitancy around adopting a new technology. And
have you worked on a commercial project with it?
Only in the study stage, not in production.
And that's wild to me, isn't it?
Yeah.
Are you surprised?
It's funny, like, not many people want to be forerunners, right?
No kidding.
Yeah. So yes, I think they are a great solution for retrofit. However, I think so. There's potentially the weight issue, right? So if say, for example, you're in a building that has 6-on-6 in a standard frame, and you go to, what would it end up being? Two 4s in a VIG and a 6.
And a 6 or 3.
Or maybe a 5, or so you're adding a little bit of weight. But you should be able to do that within the same glazing pocket, because that's the other driver, right? Like, what's your glazing pocket availability? And then, you made the comment about it's not your whole system value. I totally agree with that. And actually, framing is almost more important than the glass, right? I've worked on too many projects where everyone focuses on the value of the glazing and they completely ignore the frame. And it's like, okay, well, let's get a really, really good double glazed unit and put it in an amazing frame. And you're going to end up with a better window thermally than maybe a triple glazed in a lousy frame, right?
This is really kind of low hanging fruit, and I didn't want to bring this up, but even the simple concept of eliminating some of the mullions. I mean, I see punched window designs with these little lights.
Yeah, I know.
And I'm like, if you just do a large fixed window with a R5 center of glass, you're gonna get a pretty damn good overall U value of your assembly, which it's a little bit of a, I don't want to go down that rabbit hole, but.
So I've seen, like, again, I kind of go back to commercial office because those are the easiest to reglaze, and because those systems don't really deteriorate, right? A lot of older single glaze or a lot of older punch window systems are not drained, right? They may be face sealed. They may have like a really lousy pour and debridge thermal break. They're not
in Toronto,
easy to.
Do you have any single glazing left, or it's essentially?
Yeah. It's still here. Yeah.
So that could be a great use case, right? For a standalone VIG, not a hybrid insulated assembly.
Yeah, for a standalone VIG, possibly heritage, right? If you're like a steel sash window or something like that, and the weight would be comparable. So yeah, I think that's a good use case. You're not going to get an R10 out of it, right? You might get a really good double glaze value out of that system, right? Considering that it's going to be in a non-thermally broken or heritage type window. I think where I would go though with the single glazing is that, to my earlier comment, a lot of those systems were not rain screen drained designs, right? So you had single glazing in a face sealed window. Well, to go to the expense of putting in a VIG in a face sealed window, I would question whether that's the best kind of long-term solution, because you're not, like, then you're just doubling down on face sealed solutions, which are super risky.
So I think on a last note, which will be fun to look back on one day, we talked about your 2018 talk. In 5 years, 10 years, if you could look back on this conversation, because it'll be somewhere in the hub of the internet, what do you hope to be giving on a presentation in 2030? A lot of the same issues arise today that were there and present in 2018, but where do you really foresee will move the needle the most? And you'll be explaining, this is what was going on back then. This is what we're doing today.
Yeah, that's a really good question. I would say I hope that I hope that the market more broadly understands that building envelopes are an enabler of comfortable, low carbon, durable buildings that provide high value, right? Those are sort of if that were broadly understood and appreciated, and that there was kind of a default interfacing between envelope and HVAC, right? This understanding that we are an interdependent system, right? We're not individual systems, we are interdependent. And that's really where I've spent a lot of my career, is trying to bring these spheres together, right? Design, technical, envelope, and HVAC, and trying to marry them in a way that is in service of this greater goal, right? Of very well designed, good performing, comfortable, durable buildings. I mean, yeah. And of course, that we're basically just by default retrofitting every existing building to be better than like for similar or like for like. Yeah. Connecting capital planning to performance improvement by default, and to get to your earlier question, it's kind of one of the first questions on where's the value, or how do you evaluate it? It has to be valued on the differential between like for similar or like for like and your performance improvement option. You can't say my assumption is I have zero cost and you want me to spend $20 million reskinning my building. Forget it. That's a non-starter. Well, your assumption of zero cost is completely fictitious, right? Your assumption of cost should be, I've got $18 million worth of work to do here. How is that $2 million worth it, right? Is that premium worth it for me to get all these other benefits out the back end? Like, stop focusing on this kind of the whole cost. It's got to be on the differential between what you have to spend, whether you like it or not, and what the preferred or premium or high performance solution is. Focus on that differential, and then focus on what else that solution is and allowing you to do in other areas, like get rid of HVAC equipment entirely or switch to low temp, low carbon. Like, that's the nut I think that I would love to continue to work on cracking.
I like it. Scott, thanks for coming on. This was super informative. I enjoyed the conversation.
Likewise, my pleasure. Thanks, Adrian.
All right, talk soon.